Hello everyone, welcome back. So, as we left yesterday, um, I'm going to be doing the fourth session on Rhino today, and today it would be all about transformation, as we haven't done that part so far in Rhino. I'm referring to the same file that I have been using for this particular tutorial. I have just updated this file from the first two sessions that we had done. It's more organized for the moment, and I'm gonna just continue with the transformation part of Rhino. So if you see the transformation tab, and if you just read through some of the commands which are available, you can learn like these are some of the basic, um, or let's say very familiar commands that we see in most of the softwares, 3D modeling softwares. And today doing, we would be exploring um, the transformation tools available in Rhino. So starting with move, of course, you don't have to go to transform and select move every time. You can just write move in the command bar, and that should be good to go. And you can just take any geometry, select any geometry. As you can read on the command line, it says select object to move, please enter when done. So you enter it and you take any point if you want. In case you would like to snap it, use your snaps. You can just on your snaps from this particular area where you can see grid snaps, ortho mode, and O snap on. So you can just keep your O snap on, and you can just um, put several conditions for snapping options. Like if you would like to just snap the endpoints or near region or midpoint or intersection of two geometries, perpendicular of two geometries, vertex, or you can just disable it, and you won't see any snapping happening in on your screen once you disable it. But I'm gonna enable that for the moment, and I'm just gonna pick any um, point of that particular geometry, and I can just move it as per as per as per my convenience. And to move it in ortho mode, if your ortho mode is not selected here, you can of course press shift, and what you would get is you could either, if you're not in the ortho mode, then pressing shift would eventually track the path perpendicular to that point. And if not, if you don't press shift, you can just move anywhere um, in that design space. So that's about the move command. Moving on, the next command which is available is copy. So again, copy, select the object to copy. It would ask for point to copy from, and I would take any point, say this one, and point to copy to, so I can just do multiple copy of that object anywhere I require with that point, in fact. Next transformation tool is rotate. So select object to rotate. Let's take, I'm just gonna take this object. Okay, so that's better. To rotate this object, I can just write in rotate, and it would ask select object to rotate. So that's my object that I would like to rotate. It would also ask select the center of rotation. So you can pick the center as you like. I'm just gonna pick this particular edge, and I'm just gonna take any line in the vertical axis. So I'm just using these points so that I could mark my grid, mark my axis well. And it would ask me what is the first point of your rotation. So if this is some angle which I would like to start from, then I could just specify the angle, let's say 120. So I would get my geometry rotated to 120 degrees somewhere, um, somewhat like this. So then I can just do a left click button and it would be um, and the command gets executed. Similarly, I can rotate it in 3D. So what do I mean by rotate in 3D is I ask for rotation axis. Um, you can just also rotate it with respect to your surface normal. So if you pick any surface, you can use that surface and rotate it along that particular. But for now, let me just take a start axis, um, and end axis, first angle of rotation. And let me just pick. So if I select any surface, so it takes a normal of that on that particular surface and it draws, um, so it picks the axis, which is as a normal of that particular surface, and then you can just specify where you would like to start your rotation from and how would you rotate it. So if I say I want to rotate it by 30 degrees from that particular surface, then I could have this rotated. So that's about rotate 3D. Okay, then I have scale. So scale, as we all are familiar, if I write scale, I just have to press give two reference point, and either I could scale it with some distance, let's say 10, or I can um, specify, I can just specify, um, yeah, I just need to specify a factor. So if I say 10, so it will get scaled up to 10 factor. Uh, we have share. So share would mean that you need to select a point first, another reference point, this one, yeah. So you can see how geometry gets distorted. So it depends on the axis that you pick mostly for these kind of transformations. So there is mirror. So if you press mirror, it would ask select the object and you need to specify the plane. So let's say if I take this as the plane and this as my second point, I would get a mirror of this geometry if I pick both the geometries, and if I say this is my first point and that's my second point here, I would get something which is um, uh, it, which uses this point and this point as a mirror plane. Then we have symmetry, so it would ask for, it mostly needs a curve. So if I present a curve, something like this, it would ask me for And if I say symmetry, so it would ask me for a plane. So okay, let this be the plane and end up the symmetry. So eventually you would get something which is closed and which is symmetrical. So that's how uh, this command works in particular. If I say if this is something that I want like to have symmetrical, if I am saying that okay, I want to join this and give me a symmetrical symmetry of this particular geometry, so I could just specify my uh, symmetric the plane, and eventually it would join it automatically to form something like this. Again, if I do it, let's say, and I want to have a symmetry of this particular geometry, then I'm just going to say this is my start point and this is my end point. So let me just do it in a better way. So you would get some things like this. So that's about symmetry. These are some I mean, the most other important transformation commands would come from here, like align, orient, array, um, twist, blend, and flow along curve, flow along surface. So these are some other transformation command that we might be using a lot while modeling. So I would suggest that these are the move, rotate, or scaling commands are some commands that we generally use, um, and transformation tools. I mean, transformation commands might always. I mean, it's better if we learn them in the best possible way, because it could make or simplify our work to a greater extent. Um, so yeah. Okay, so the first command that we would be looking into is align. I'm just gonna name this thing because I updated, or I was trying to organize it, but then I forgot to. And this was orient. Okay, yes. Okay. So in transform, the first command that we would be using is align. So it would ask select an object to align. Um, this is the object that I would like to align, and press enter when done. And the alignment, I need to just specify maybe a plane. So I can align it to a plane, or so let's align it to a plane, and So I can just select few things in the command bar and then okay, let me just take it to the side first. Okay, transform, align, select the object to align. I can align based on my viewports mostly. I mean, that's one way we could. Okay, it's a mess. Okay, so align type, align to the wall. I can use a plane as well. So there are different, like if you just look into the command, you would see different types of alignment options that you would get. So you can use either of these options and just align your object based on your preference. So you can take align it based. You can just select it left, right, whatever bottom. That's kind of an easy way to align. But I think there are other important tools that I feel. So this is array and that's orient. Okay, so we have these geometries. We have to orient based on 2 points, 3 points on surface on the curve perpendicular to the curve, curve to edge, and remap to C-plane. So these are different ways you can orient an object. It could be any object. Um, it could be solid. It could be polysurface. Um, basically, it's kind of a geometry that it takes in, and it would try to orient it based on all of these conditions or all of these methods. So let's say I have this geometry here. I say or transform orient with 2 points. It would ask me for the first reference point. Let's take this as my first reference point and this as my second reference point. And once my both points are selected, oh, sorry, we need to select the reference point of the object first. So this is the first and this is my second and this is my um, reference point of these reference point for this particular geometry. So that's how I can orient it with 2 points. Similarly, you can do it with 3 points. So if you have this geometry, I would say just give me, I would say like I have this curve here I have this geometry. So I would just select this geometry, transform, orient, 3 point, um, first reference point, second reference point, and third reference point, and I can just one, two, and three. So it would get oriented based on whatever target points that I select and whatever reference point that I select. Then orienting on a surface. Let's say if we have a surface like this, and if I would like to orient this particular geometry on this surface, I can use transform orient on surface, and it would ask for a base point. Let's take this as my base point, and reference point for scaling. Well, I don't want to reference. I don't want any scaling and rotation. So this is my first reference point. This is my second reference point, surface to orient, and this is my surface that I would like to orient. So you can see that it just uses the surface normals and basically orients itself uh, based on those normals. And next is on curve. So transform, orient on curve. So you have a base point. Let's take this as your base point. This as your orientation curve, and this is your new base point. Did I select any other object? Okay. Select object, the base point, which is this, and select orientation curve, this one. So you can see that my object gets oriented based on this particular um, with this particular base point that I select for an object, so it gets oriented to this curve. Okay, what else do we have? We have perpendicular to the curve, curve to edge, and remap to C-planes. I would say that like the ones that I'm trying to show you are something which you could which you would be using more. The reason for me not showing the rest of the command would be um, because these are kind of some commands which you could learn it, um, but it won't be so useful. I mean, it depends on the way you are trying to model some things, but yeah, just give it a try in case you want to learn about, or if you get curious about how these tools react. So yeah. For arrays, let's take a geometry here, and let's do some. Okay, so it's my geometry, transform array. If you want to do rectangular array, you select the object. You Yeah, you need to specify the number of objects in x direction. I want to say 5. In y is 5. In z, let's say 3. And the spacing that I would like to give um, in x, let's give like 5. In y, let's give 6. In z, let's give 5 again. So this is how my geometry would be formed based on the array that I'm doing here. So you can just select this. Again, I'm just gonna repeat this. Let's do it with 2, 2, 2, and let's say I want to have 5, 5, 5. 2, 2, 2 in X, 2 in Y, 2 in Z. X spacing would be 5, Y spacing would be 5, and Z spacing would be 5. So this is how I would get my geometry if I do a rectangular array. Okay. Next is polar array. So we go to array, polar, and we have this geometry. Enter when done. Center of um, polar array. Let's pick this as my center. I would say I want to have 5 elements starting from here to 360 degree, and you can see I can also give a Z offset. So if I give uh, 3 units as my Z offset, then I could see that it also takes an offset in my Z direction. So if, for example, if you would like to create a rectangle or a circular staircase very quickly, you can use polar array for that purpose. It could be quite useful. Again, arrays, linear array, 5 first reference point, and then you can see I can specify my second reference point for spacing. If I say 5 units, it would lock everything at 5. So you can see, so that's gonna be my linear array along a curve, along a surface, along curve on surface. So I think we have some reference curves here. So let's take this two geometries to demonstrate transform, orient, array along a curve. Select the object to array. That's the object that I would like to array. That's my path. And number of items. Let's say I want to have 4 items or 5 items. You can select the orientation. You could have no rotation. It could be free roam, or it could be kind of a road-like. So if I say road-like, click a viewport to choose a C-plane. So I need to just click on, again, object, select the path, and then let's go to transform, orient, sorry, array along curve, select object, path, road like. Okay. Okay, so I need to click in the C plane that I would like to have my orientation. If I select freeform, it would eventually like take a freeform and just adjust itself based on the tangent. So if you see this you can see that it just follows the tangent of that curve at that point of that curve, and it eventually orients the object along that curve. Okay, so that's orienting an object along a curve. Then we have orienting an object along a surface. Okay, so we have the surface, we have the object. Sorry, we need to do an array. So yes, we have an object to array. We have the base point of the object, reference normal for object to array. So let's pick this as my z-axis. Select the target surface. Number, maybe I would like to have 10 and 10 in U and V. So you can see that my surface is oriented to its normal. So the selection that I had done earlier, so if I select this again, select the object, it asks for a base point. So let's say this is my base point, it asks for a z axis. So if this is my z, and it asks for a target surface, so let's do 3 and 3. So you can see that it just aligns it, it just um, it just does a whole an array based on the normals of that particular surface at that particular point. So you can see that the z-axis that we selected, it remains as a z is equivalent or more or less the z-axis of that surface at that particular point. So that's my array along a surface. Okay, what are some other tools? Along a curve on surface, I think you can just give it a try. Next, I would go to twist. So, as the name suggests, and it's kind of a good transformation tool that we could use while modeling. So, what does twist do to your geometry? Once you have a geometry, you do transform, twist, and you select the object, and you specify the start and end of the axis, and start and end of your like twist. So if I'm twisting it like for 360 degrees, I would get some things like this. So that's my twist command. So you press, select the object, select the axis, and give the angle of rotation. So if I start from here, I could just rotate it back at that point, and that's going to be my 360-degree rotation. Okay, so that's twist. Next is transform bend. So select the object to bend, start of the spine, end of the spine, and it would eventually try to bend it. You can have different options here. You can have your angles, you can um, make it rigid, so the bending won't be like so fluidic. So if you don't want that, you can off your rigid. You can just say that I want more smooth bending. So you can see that it's bended well. So that's bend. Next, transform, taper, select object, enter when done, start and end axis, and then starting distance and ending distance. So you can just taper your geometry. If I would have selected my center as a center of this particular polygon, um, the tapering might have happened more evenly on all sides, but because I selected this side as the center, so in that case it has just taken that axis as a reference, and based on that it has scaled both ends of this geometry. So that's but these kind of uh, works could definitely give you some really cool output, uh, which we could definitely play and do some form finding. So it's worth trying different kind of transformation. Um, Again, stretch, select object to stretch, press enter when done, start of the stretch axis, end of the stretch axis, and you can just see that I could stretch these elements. We have flow along curve, so let's take a surface, sorry, a curve first, and then let's say transform flow along curve, select object to flow, enter when done. Is it recording now? Yeah, I don't know what happened, but I just crashed for some reason. It's weird. Okay, so we were on, let me check again if it's working fine. Seems it's fine. Okay, so we have transform array linear. Okay, so let's say if I have so much. Okay, let's say I have this geometry and I would like to follow it along this particular curve. Okay, so in that case what I could do is transform, follow along curve, select the object that I would like to, so these are my object, select this curve as a reference curve and select this curve as your target curve, and you can see that this particular geometry, it just takes it just gets easily uh, oriented along this particular curve. So that's an easy way of uh, orienting a geometry along the curve. Okay, and then we have along flow along surface. So let's pick a surface, transform. Okay, so we need, let's say we have a sphere. Okay, let's have this as my reference geometry, and I would like this geometry on this particular surface. So in that case I would say transform, flow along surface, select object to flow along the surface, this, press enter when done. Base surface, so if this is my base surface, and target surface, so if this is my target surface. So if you say that I have like multiple geometries like this, which I could easily take from this surface to the other surface that I am targeting. This could be an easy tool. I'm just doing some transformation here, and so let's do a flow along surface, and it would ask me for some objects. It would ask me for a base surface, and it would say give me a target surface. So this is how it would, so you would see the geometries would be a bit distorted because it eventually tries to remap these geometries on this particular surface. So depending on the change in the topology, um, there could be a change in the geometry which gets um, kind of replicated or copied on the other surface, that on the target surface that we are. Okay, so now is another good thing to explore in transform is the gauge edit. So imagine, let's take this particular geometry and let's use this geometry for it. And what I could do is, so basically when we talk about gauge editing, Um, you can put any geometry. You can say that you are taking a geometry, you're putting that in a cage, and you just um, molding the cage, or maybe um, modeling the cage, and eventually whatever is inside that cage um, gets modeled as per as the way you have modeled the cage. So I mean, I'm just gonna show it to you so that it gets a bit easier for us to understand. So let's take this geometry. It would ask me for different ways we could do the cage editing. I'm just gonna select bounding box with the world plane, yes. And it asked me to select, it asked me what are the number of counts, number of points that you would like to have in your X, Y, and Z direction. I'm just gonna select the default and the degrees are the same. So once you do that, you see this cage kind of, or a bounding box, which appears if you on your control points. Okay, you would see that I have control points in all directions. So I had selected 4 in X, so I have 1 2 3 4 in X, 4 in Y, 1 2 3 4 in Y, and now I have like 4 in Z. So 1 2 3 4. So these are all the points that I have. Now whatever I do with this cage, my the geometry which is inside this cage would be modeled as per the way I modeled this cage. So if I just do some things like this, why is there a problem? Let me just do the cage editing again. Bounding box. This works. Why not? World plane X Y Z. Yeah, and it has to be global. Okay. I think now it should work. So as I edit this whole cage, my geometry gets edited as well. I can take in all of these points, and I can just do any kind of uh, transformation, um, or maybe model the way I want it. I'm just gonna take these points maybe a bit on the inside, so you can see I will get some things like this. Um, so if you want to have some things which is quite intricate and which requires a lot of detail, maybe you could use cage editing tool. It's quite useful. Um, so you can use this for various purposes. Yeah, and anytime, like if you switch out of this editing mode, you can just select the cage and on the control points, and you should be able to um, you should be able to get these points again, and then you can just start to again edit these things the way you want. So yeah, so that was about cage editing. I did some exercise using cage editing. I think this is one exercise that I would do once we go ahead um, with some more tutorials. I think for now, more or less, we have completed the basics of Rhino. We have learned the interface, we have explored most of the tools available in Rhino. There are a lot of things you can do apart from just using these commands. You can give dimensions in to your geometries. So if you want to know the dimensions, you can use these dimensions, and you can have the dimensions here. So you can explore the dimension tab as well. You can give leaders, you can give hatch, you can make 2D. So if you select any object, you can easily make 2D. You can easily make a 2D version of that particular viewport using the make 2D command. You can do a lot of analysis as well. So one particular analysis that I could show you is, if for example, if I want to check the direction of this particular curve, I can go to analysis and direction, and it would show me the direction of this particular curve. I'm just gonna have another curve here, and I'm just gonna say flip. So what it does is it flips the direction of that curve, and now when I check the direction of both the curves, I would get two different. So my direction is somewhat in this way, and here I can see my direction going the other way because I flipped that curve. So you can do some analysis as well. You can of course render um, your geometry. So there are other rendering options that are available as well. I'm not gonna go in detail with all of the commands which are available. You're free to explore. I'm more concerned with the 3D modeling part, so I'm trying to make create these sessions based on modeling in particular. So that's why learning some of these useful commands are necessary, or could help you do some modeling better in Rhino. So that's, I think, something that I have for you for the moment. And eventually, as we go ahead, we would explore all these exercises. Um, and there are a lot of exercises that we could do. We could have, and it could be like, it could be furniture scale, it could be architectural scale. So it just depends on your preference as such. But yeah, we would like to explore all kind of things that we could with with Rhino modeling. So yeah, I think that's all for today. Um, cool then. See you next time.